Hi everybody, this is Mr. Short. Today we're going to draw 5 Lewis structures. Before we get to that though, I just wanted to review some of our objectives. Mainly right now we're focused on objective 2, which is about Lewis structures following the octet rule. Remember, the octet rule says that atoms, by gaining or sharing electrons, have to have 8 valence electrons around them, with the exception of hydrogen. The other thing that I'm going to emphasize today is this last statement that we have down at the bottom. It says, when drawing Lewis structures, space out bonds and non-bonding electrons as far as possible. This is a little preview to information that we're going to cover next week concerning an acronym VESPER. VESPER stands for Valence Shell Electron Pair Repulsion Theory. The basic concept here is that pairs of electrons will repel from other pairs of electrons. Because they repel, we have to draw them as far away from one another as possible. That's something that we're also going to emphasize today. We're going to be following the 5 steps for drawing Lewis structures. You should have that sheet out with the 5 steps in front of you. At the beginning, I'm going to go fairly slow to emphasize those 5 steps, but then we'll start to pick up the pace a little bit. This first chemical right here is called formaldehyde. You can see it's got a carbon, 2 hydrogens, and an oxygen. And step 1 says that we need to account for the total number of valence electrons in the final structure. Valence electrons, remember, are determined by taking a look at the element's main group number. The main group number, 1, 2, skip a few, 3, 4, 5, 6, 7, 8, tells you the number of valence electrons in the neutral atom. So for example, hydrogen is in main group 1, 1 valence electron. Carbon is in main group 4, and oxygen is in main group 6. So the accounting would look like this. Carbon has 4 valence electrons, plus each hydrogen has 1 valence electron, but we do have 2 hydrogens, and oxygen has 6 valence electrons. 4 plus 2 plus 6 is 12 total electrons that we need in our final structure. The structure is going to look like this. It tells us that carbon, because the element carbon comes first in the molecule, is going to be the central atom, and all other atoms are going to radiate directly from carbon. So we're going to draw carbon in the center, and I'm choosing to draw oxygen up top. You could put it on the side if you want, and that's perfectly fine. But notice how this looks like a peace sign. The reason that it's drawn like a peace sign is because, remember, when drawing these Lewis structures, we need to space out the bonds and the non-bonding electrons as far as possible, according to VESPER theory. Spot that around carbon, I currently have 6 electrons because each bond represents 2 interacting valence electrons. So I've used 6 out of the 12 that I have to use for this structure. So according to step number 3, which says to add 6 more electron dots around everything except the central carbon and never to hydrogen, according to that rule, I'm going to start my counting at 8 and I'm going to stop at 12. Because here's 6, 8, 10, 12. Step number 4 is about leftovers. Because we've used 12 electrons and we have 12 to use, there's 0 leftovers. So we skip step 4. Step number 5 is about 2 parts. I'm going to emphasize the first part right now. Step 5 asks you to check and make sure that all atoms, with the exception of hydrogen, are following the octet rule. Carbon, you should spot, only has 6 electrons around it. 2, 4, 6. For that reason, we need to cross out and share. This is called a double covalent bond, and each of these are called single covalent bonds. Now remember, at the end, there are 2 double check steps that you should take. Step 1 is to make sure that you've represented all 12 electrons. Tap and count by 2. 2, 4, 6, 8, 10, 12. Step number 2 for double checking is to make sure that each atom, with the exception of hydrogen, is following the octet rule. So here's carbon. Carbon has 2, 4, 6, 8 around it, so it's stable and happy, following the octet rule. Here's oxygen, 2, 4, 6, 8. It's following the octet rule. So this is our final structure for formaldehyde, CH2O. Here's the accounting for carbonate polyatomic ion. You can see that carbon is in main group 4, and that oxygen is in main group 6. So the accounting looks like this. Carbon has 4 valence electrons, Oxygen has 6 valence electrons, but we've got 3 of them. And then we also have to account for this -2 charge. Remember, electrons are negative, and because this has a -2 charge, it means that it has 2 extra electrons, so we also have to add 2 electrons. That adds up to 24 total valence electrons. Skeleton structure, we'll have carbon in the center because it's first in the formula. We want to evenly space out. Again, it looks like a peace sign at this point. I've used 6, but I want to use 24. Step number 3 says we're going to add 6 more electrons to everything, but never the central atom and not to hydrogen. So I start my counting at 2, 4, 6. I start my counting at 8, and I end at 24. So here's 8, 10, 12, 14, 16, 18, 20, 22, 24. Step 4. We've used 24 and we have 24 to use, so we have 0 leftovers. Step 5 is about checking to make sure that everything is following the octet rule. You should spot that these patterns right here are identical and they represent 8 electrons around each of the oxygens. Carbon, though, only has 6. So in this case where we've used all of our electrons, but carbon isn't following the octet rule, we need to cross out and share, just like we did above. Remember, the last part of step 5 says that if you have a charged polyatomic ion, you need to draw the structure in brackets and put the charge in the upper right-hand corner. All right, sulfur dioxide. Sulfur is in main group 6. Oxygen is also in main group 6, but we have 2 oxygens, so we have a total of 18 valence electrons. Sulfur comes first, so it's the central atom. Now normally when you draw these, you want to draw them spread out as far apart as possible, but I can do a little bit of advanced planning. I've been doing this for long enough to know that it's actually going to take a bent structure, and you're going to see why in just a minute. So this is our skeleton structure. I've used 4 out of 18 electrons. Step number 3 says to add 6 more electrons to everything, but never the central atom and not to hydrogen. So I'm going to start my counting at 6. 2, 4, here's 6, 8, 10, 12, 14, 16. And I stopped there because step 3 says don't add it to the central atom. Step 4 is about leftovers. I've used 16, but I have 18 to use. So I put the 2 leftovers on the central atom according to rule number 4. Step number 5 asks about the octet rule. Again, pattern recognition. You should spot that this and this is a pattern for 8, but this is a pattern for 6. 2, 4, 6. So what do we do when we've used all of our electrons, but something isn't following the octet rule? We cross out and share. Because these electrons are up here, they are repelled from this region of electrons and also from this region of electrons. So if you were to take a look, you could see that there's a region that's here, here, and here, and they are in fact getting as far away from one another as possible. So that's our final structure for SO2. Next one, nitrate polyatomic ion. Nitrogen is in main group 5. Oxygen is in main group 6. Having a negative charge means that it's gained an electron. So this adds up to 24. Nitrogen is going to be the central atom because it's first in the formula. So I'm going to put my nitrogen right there. We have 3 peripheral atoms, so spacing them out as far apart as possible will again make it look like a peace sign. I've used 6 out of 24 valence electrons, so step number 3, I add 6 more dots to everything except the central atom and never to hydrogen. So 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Step 4. I've used 24 and I only have 24 to use, so there's 0 leftovers. Step number 5 is about the octet rule. Spot that this pattern right here around nitrogen represents 6. What do I do when I've used all 24 but the central atom isn't following the octet rule? Cross out and share. Last part of step 5, draw it in brackets since it's a charged polyatomic ion, and put the charge in the upper right hand corner. last one. N2 is diatomic nitrogen. About 78% of the gas that we're breathing right now is diatomic nitrogen. Nitrogen is in main group 5, so it's got 5 valence electrons, but we have 2 of them, so we have 10 total electrons. One thing that you should spot when you take a look at all of these is because electrons come in pairs, we always have an even number of valence electrons. You got to be a little bit flexible with the rules here because since we only have 2 atoms, nothing is truly in the center. So there's our skeleton structure. I have to distribute the remaining 8 electrons across these 2 atoms right here. So here's 4, 6, 8, 10. I've used all 10, so I have 0 leftovers. Spot that this is a pattern for 8, but this means 4. What I do is I cross out and share. This is still following the octet rule, but this one still only has 6. So it's the same question. What do I do when I've used all of my electrons that something isn't following the octet rule? Cross out and share. In this manner, we now have what's called a triple covalent bond. Now note that we can only have single, double, and triple covalent bonds. It doesn't go beyond that. We've used all 10 of our electrons, and both of these nitrogens are following the octet rule, so that's our final structure for diatomic nitrogen. All right, thanks a lot, guys. See you soon.